All right, so this question gives us a circuit already in the Laplace domain. We have a 6 over S volt voltage source, 6 ohm resistor, 7 S ohm inductor, 1 over 9 S ohm capacitor, and an 8 ohm resistor. And we are asked to find the Thévenin and Norton equivalents. So we have to simplify the circuit to find Z Thévenin and VOC and ISC, and then draw the Thévenin and Norton equivalent. Okay, so the first thing we can do to simplify is combine these two impedances, the inductor and the 8 ohm resistor, because they're in series, so we can simply just add them up. Place resistor with a short, and represent it as a general impedance of 7S plus 8 ohms. Okay. And now we can't do any more impedance simplification until we make a source transformation. We can transform this voltage source because it's in series with this resistor, and we can make it into a current source that is in parallel with that resistor. So we have to find what the value of that current source would be. So we'll just say I1, call this V1. I1 equals V1 over Z. We'll just say that that is for the 6 ohm resistor. Okay, so that's simple. That's just 6 over S volts over 6 ohms, and that just gives 1 over S amps. So this will be the value of the current source, and then the current source has to be pointing in the same direction as the positive on the voltage source, so I'll draw that. Current source will point to the left. Don't forget to draw your arrow for I and your voltage as well at the terminals. And then that 6 ohm resistor will be in parallel with the current source. Then we still have this capacitor here. So this is 1 over S amps, 6 ohms, 1 over 9 S ohms, and then 7S plus 8 ohms. Okay, so now we can combine the resistor, the 6 ohm resistor, and the capacitor, because they're in parallel. So to find their equivalent impedance, say Z equivalent equals, and then the product over the sum. So 6 times 1 over 9S all over 6 plus 1 over 9S. And that gives us 6 over 54S plus 1, because we just multiply the top and bottom by 9S. That cancels out this term, and then leaves it 6, and then 54S plus 1. Okay. Ohms. So that's the combined impedance of these two. So I'll draw that. current source stays the same. 6 over 54s plus 1 ohms, and then 7s plus 8 ohms. Okay, so now we can't combine any more impedances, so we need to do another source transformation. Because this current source is in parallel with this impedance, we can turn it into a voltage source that will be in series with this impedance, and then therefore the entire circuit will be in series, and then we can add up these two impedances, and that will be the Thévenin impedance. And then we can find the value of the voltage source from that would be VOC, and then we'll have to do another source transformation to get the Norton equivalent, or the value for ISC. Okay, so now to transform this current source, okay, so I've redrawn the circuit as it was, and now we have to transform the current source, and we'll do that. The value of the voltage source resulting from that transformation will be, say, V equals IZ, where I is 1 over S amps, and Z is 6 over 54S plus 1 ohms. So the resulting value of the voltage is just going to be 6 over S times 54S plus 1 volts. Okay, so now I'll redraw with the two impedances in series with the voltage source. So the value of the impedance stays the same in the source transformation, 6 over 54S plus 1 ohms. Voltage source is 6 over S times 54S plus 1 volts. And then this impedance still carries down, 7S plus 8 ohms. So now we need to combine these two impedances in series. So their combined impedance, Z equivalent, is just 6 over 54S plus 1 plus 7S plus 8. All of that's in ohms. And so we need them to have the same denominator. So we'll multiply, not going to expand that, so we'll just say 6 plus, we'll not expand it yet, 7S plus S times 54S plus 1 plus 8 times 54S plus 1, and then all over 54S plus 1. Okay. And then we can expand it out, and it just becomes a big polynomial. If you wanted to, divide out by 6 or something, you could do that, but I wanted to avoid decimals. So we have big numbers instead. So that'll simplify to 378s squared plus 439s plus 14 all over 54s plus 1. and these are ohms. Make sure you're on the exam, you write down all of the steps, show all of your work. So this is our combined impedance for those two impedances. So now we can redraw the circuit. Now we just have the voltage source in series with the impedance. So now this is the Thévenin equivalent circuit. So we have our VOC and our Z Thévenin. So I'll write here that this is the Thévenin, and then now we have to find the Norton equivalent as well, and we can do the source transformation pretty simply. We'll just use the formula. So first of all, VOC equals, what is it, 6 over S times 54S plus 1 volts. Then Z Thévenin is that long thing. Doesn't necessarily have to be super simplified because we're not going to be doing an inverse Laplace, as long as it's clean and simplified. Okay, so then our ISC is just equal to VOC over Z Thévenin. And importantly, for VOC, the positive aligns with the positive that we have defined for our variable V here. So that's important, so that lines up. If this source were flipped, we would have to say that VOC is negative. So just pay attention to the polarity. Plug in the values here. So the voltage is 6 over S times 54S plus 1 volts, and then just to make writing it simpler, just multiply it by the reciprocal, which is also the admittance. So that's just 54S plus 1 over 378S squared plus 439S plus 14. And since I've written it that way, it'll be in Siemens. And then that just simplifies. Solve that. And we get ISC is equal to, well, these cancel. So it's pretty simple, just 6 over S times this quadratic here. Okay, and then that's in amps. volts times Siemens amps. That's our ISC. And then, so now we've drawn our Thévenin circuit here. We have all of our values. Now we just need to draw our Norton circuit. Make sure you're paying attention to the direction of the arrow. And then the value of the impedance is just going to be our Z Thévenin. 378 S squared is 439 S plus 14 over 54 S plus 1. And value of the current source is ISC, because we have the arrow pointing in the same direction as the way we've defined I there. Again, just like what I was saying before, if this were flipped, the voltage would be negative, VOC would be negative. Same thing here, if this source were pointing downward and this I were still pointing to the left, we would have ISC be negative. So again, just pay attention to the polarity. So the current source is 6 over S times 378 S squared plus 439 S plus 14 amps. And this is our Norton. So on the exam, if there's a question about Thévenin and Norton, make sure you show all of your steps, draw every change you make to the circuit, and in the end, you should have VOC, ISC, Z Thévenin, and you must draw your Thévenin and Norton circuits.